In this tutorial we will continue to work on our car game project. First of all, I will make a transaction between this, our testing track, and I will create another track from prefabs. So here, if we go to the bed drill track, here we can open an example and copy this track onto our scene. So I will select these elements I don't need plane as we already have it, and I copy them, Ctrl C, and open our scene we worked before. Here, we can name it as track 1. Track 1. And I can name this one as track 2. And place these parts here as a child to the track 2. Then I will rotate it and make the finish line near that finish line. So I rotate this track somehow. Disable the previous one. Also I need plane from here. So I copy it, Ctrl C, paste here. Next I need to locate all of the checkpoints around the track. So it will take some time. Also I will disable the canvas so it won't bother me. And locate all of the checkpoints. Our race manager checkpoints. After that I need to check that all of them go in the right order here from 0 to the last one. So this finish checkpoint I need to move down and continue checking all of the checkpoints. Now I see that all of them in the right order. Also I can increase size of them. So it will be more easy for cars to hit them. After that I need to also move all of these checkpoints to our race manager. Here, delete these checkpoints. Also fix this window here by clicking this lock button. After that I select all of the checkpoints and drag and drop them to the race manager script. So now I can see all of the checkpoints here and they should be numbered. Also once I drag and drop them here, I can click unlock here so that I can manipulate with the checkpoints. I will also disable mesh renderer, so I will only see nothing here. And now I'll try to drive around all of them and see whether the lap will increase or not once I finish the lap. So for this procedure I need to activate canvas first in order to see laps, and I start the game. Also probably disable the car sound, engine sound here, and we'll drive around. And see on my lap. So after that we will add some enemy cars to our game, so we'll drive together. Not only player car will be drive, but we can also compete with some other cars. So now we can see that lap was increased. So now let's add additional cars to our game. So I'll copy the car, name it as AI car, and also add additional AI cars for cars. And change color for them. Materials, for example, one car will be red, another black, and add two additional materials, for example, one green, and another one blue. And also add these materials to cars. So now if I start the game, as all of this car has the same script, they will drive around the same way as our player car. So we wanna add the custom behavior to this car, so they will drive automatically. Also, as I added these cars, here on all of them we need to disable audio listener, as it should be enabled only on our car, so other cars don't need it. So what's the idea of the behavior of our AI cars? Our checkpoints have a location in the world location, and for these points we'll get these points of our checkpoints, and our AI cars will drive around these checkpoints. And in order to add some diversity, so not all the cars will drive the same way, we also make this position different for cars, add some random range. So the idea is following: first of all, the AI cars move towards the target. Once it reaches the target, it will forward towards the next target. And once it's hit the second target, it moves to another one, get its position and move towards this position. So we need to manipulate with the speed of the car and also with the steering of the car in order to be able to rotate the car in the world space. So first of all, we'll add the understanding what is the player car and what is the AI car. So we go to our car control script, and here we add public bool variable is AI to understand what is our AI object, AI car. First of all, we need to separate the behavior of our player car and AI cars. For example, this current lap text should be displayed only for our player car. So here we add the statement if it's not AI, we display these things. If it's our player car, if it's not AI, we display the current lap text for the car. Next, let's scroll down. Here we have our speed input and turn input, where we manipulate with the buttons. So here we also need to separate these things from the AI car. So here I write if is not AI, we operate with our buttons. Move it here. Otherwise, AI cars have their own behaviors. But here for our player car, we manipulate with the vertical axis, which means up arrow button or bottom arrow button, and with the steering turn input, the left, right keyboard buttons. Next, we scroll down, and here, where is the lap completed? So here, the lap completed, the best lap time will also need to display only for our AI car, not AI car, our player car. So here again add condition if is not AI. We display best lap time and lap current counter text. So these things we need to also place here. Now I save these things and go to the Unity and try to activate this bool variable on my AI cars. So only now the player car will move around the space. So here I need to enable is AI. And now I will be able to drive only my player car. Other cars will stop. So now let's add some behavior to our AI cars. For this procedure, first of all, we'll create additional variables in the beginning. So first variable vector 3 variable will be named as target point. It will display the position of the target. Pose of the target. Next variable here probably public int current target to know what is the current target. So once we reach one target, we move to another one. So current target, what is our car drives towards. Next variable, public float AI accelerate speed. Acceleration of the AI car equal to 1f. Next variable, AI turn speed. How fast car can move on the journey. 0f. So on straight line and on journey, the car have different speed. Next variable, AI reach point range. So what is the AI reach point range? Once car close enough to the target, it aims to another point. So by this variable we add some diversity. So not all of the cars will drive the same way. And also we add some diversity also by another variable, AI point variance equal to 3f. Also by AI point variance will be used for adding some diversity to the current target position. So it adds some diversity to the current point position, and this variable AI reach point range if the car close enough, if the distance between target and car around this value, so car simply aims to another value. Also I will add another variables, private type of variables, float AI speed input to control speed of our car, and AI speed mode. So different cars will move with different speeds. So it also make the behavior more interesting. So not all of the cars will move the same speed. Next, in the start, we need to first of all understand what is the target point, what's its position. So here we write target point equal to, we get targets from our race manager as it stores our checkpoints, and we need to get position from our checkpoints. So we get access to the race manager script. This script is a static, so we can simply write here race manager dot instance, and then variable we need to get access to all checkpoints and current target. Transform position. So here we provide current target number and get the target position. And we need to add the diversity to this target position, so we add additional function for it, for adding some diversity to it. Here, write public weight randomize all target. Point and we increment this value by new vector 3 random range minus AI point variance 2 plus AI point variance. We do not touch the y-axis, so our target has 3 axes here. The red one is x-axis, the blue one z-axis, green one y-axis. So we need to simply get access to the z and x axis, and the y-axis the current position of the car. So we will take it from the position of the car. So here I simply write 0f, and then we will specify the car position here for the y-axis, so it won't go down or up, it will stay the same. And for the z-axis it will be similar, random range minus AI point variance plus AI point variance. So we need to call this function here. And it needs to work only for our AI car. So here we add condition if is AI. We doing these things. Okay, semicolon. Next here, if player card has this behavior, then our AI cars need to have another behavior. So here we write else. Else means that it is AI. So here we add another condition for our AI cars. So first of all, I need to obtain the y-axis of my car for the target point. Specify this y position. So here I simply write transform dot position dot y. So this script is attached to our cars. So I use transform position y, which means the y position of the car, and I give it to the target point. Next, if current target. First of all, if vector 3 distance transform position target point smaller than AI reach point range, then we increment our target. So here we compare the distance between the car and the target point. So if it's smaller than the AI reach point range, so we can aim to another target. So here we increment our target, current target plus plus. If current target bigger or equal to race manager instance all checkpoints length, then we reset our target to the default position, current target to the default number 0. So which means that we have finished the lap. And once we finish the lap, we again need to add some diversity to our target. Again, get position and add some diversity here. Now our AI targets have this variable for controlling the checkpoints. So now we will try to test these things here. And probably I'll add mesh renderer. So I'll move the car around the checkpoints. Currently I cannot drive the AI car, so I'll try to move it around checkpoints manually. So for this procedure I need to start the game. Then I need to find sphere of the car, police a car, because so this is the finish checkpoint, so it won't be seen here, but here is the first checkpoint. I will try to move my car to this checkpoint and check what's happened. Nothing happened because probably I also need to place the sphere here to my car. It has this sphere. Make it child with regards to the car and try to move the car again. Again, nothing happened to the target. Current target, why? Okay, I was in a pause mode. Okay, let's try one more time. Yeah, in the game mode I won't be able to move my car because I need to locate sphere as a child to the car. So this sphere as a child. And also I need to disable the gravity mode on my sphere so it won't fall down. Okay, now let's try to move the car. On sphere. Oh my god. Again, locate sphere here, disable gravity, and probably also need to disable sphere collider. Try to move. Okay, let's at least reach the first checkpoint by the Owen sphere and check whether it's increased or not. Okay, current target was increased. Let's continue our scripting. And hopefully everything will be fine later. I just wanted to move car around to check whether it will be current target raised here on the finish line to the default position. Now it's difficult to move car around. So let's currently leave it this way. So disable this mesh renderer and move to our script. So let's try to make our AI cars to move. So here we have our condition for our AI car. Once we get the position of the target, we once we first of all need to get the direction to the target. So here we write vector vector 3 target dir. For this variable will be used for evaluating how far we are from the target. So here target point minus transform dot position. So the position of the target minus position of the car. So how far we are from the target. Also we need to understand the angle between the car and the target for rotating our car respectively. Float angle, new variable for the angle, vector 3 angle, target dir, transform forward. So transform forward, so where our car move this z-axis forward, and target dir the target point. So we get the angle between these two vectors. So calculating angle between car and the target. And here we won't be able, by this function, we won't be able to obtain the sine of the angle. It always will be the plus sign. Doesn't really matter where the car located with regards to the target, it always will be the positive. So we also need to obtain sine of the angle. So for obtaining sine of the angle, we use another function. Vector 3 local poles equal to transform inverse transform point target point. Then if local poles x smaller than 0, then angle is negative angle equal to minus angle. So that's how we can obtain angle, sine of the angle. First of all, detect current poles, and if it's smaller than 0, then angle is negative here. So now we can move to the speed of the car and steering of the car. First of all, let's try to test whether our AI car will be moved with the default speed, some constant speed or not. So AI speed input equal to 1f. So first of all, we want to move our car by that constant speed. Then speed input equal to AI speed input multiplied by forward acceleration. So now if I start the game, the cars, all the AI cars will move forward with the constant speed. And I didn't add any turn control, so they will simply move forward. That's all. Now let's set some control here for the speed of the car. So as we discussed previously, on our straight line we wanna move car with one speed, and on turning we wanna slightly decrease the speed. So here we need to use the condition if math dot base angle smaller than AI max turn. So let's set the variable for AI max turn here. AI max turn. How the strength for the steering 25F. Previously we defined the max wheel turn as 25, So the angle of steering, so let's also make it 25 here. So the strength of the rotating for our car. AI max turn. So this condition simply means if it's smaller, if angle is smaller, that means that we are on a straight line. So here our speed input, AI speed input will be equal to math move towards AI speed input will be equal to 1f on a straight line, and acceleration speed else means how fast we will accelerate our car on turning. So I can copy these things, and here I'll write AI turn speed. Also, I don't need this AI speed input any longer. The default speed as it's calculated from here. Also, now let's manage the turn input. Here it will be equal to turn input. For our player car, we control turn input by our keyboard buttons, and they have value from -1 to 1. So for our AI car, we also will use these numbers from -1 to 1. Clamp angle divided by 25. It's not by 25, but our AI max turn. And we scale this value from -1 to 1. So this is our turn input. So the angle we obtain, we simply divide it by 25, as we want to limit our turning on 25. So even if the angle is 30, we still scale it with a -1 to 1, and we limit this value by 25, the maximum turn speed, turn strength. Now let's try to test these things. Car will not rotated. Let's check again why they will not rotated towards the target. We also need to make one of the replacement in our script. Here we scroll down and need to find the statement. Where is it? If grounded and input getAxis vertical not equal to 0, we transform the rotation. So first of all, these things I need to move out, as they should be used for not only for player car but for the AI car as well. Transform rotation of the car. So let's save it first and then I explain another thing. Now we can see that cars move around the track. They collide with each other, so probably I will also disable the hit sound so it won't bother us. But now, currently I drive together with the cars, but currently I wanna just stay here and see what will happen. So simply cars will go only straight way and they won't turn. So why did it happen? Because here we have a condition if grounded and input getAxis vertical only under this condition. Simply, in other words, when I turning, then the other cars can turn as well. And when I don't turn, when I don't drive around, the cars won't turn. So here we can simply replace this statement. So I can replace it with the speed input. This simply the same. If car moves, only then we can rotate it. So otherwise we won't be able to rotate it. So here we added previously, we just don't wanna rotate our car when it stays, when it doesn't move. When it doesn't move, we won't be able to rotate it. So now if I start the game again, and I will stay here, the AI cars will behave normal. So they can drive around without any problems. And now we can probably check the current target, whether it will be raised in the beginning or not. Yeah, it was raised in the beginning. So where is it? Disable the hit sound. Sphere, smash sound. Probably here. Now let's try to also randomize speeds of our car so they will move with a different speed. Back to our script. And here, first of all, on start, we write AI speed mode equal to random dot range .f 0.8 f 1.2 f example. And we need to add the speed mode to the speed input calculation here. So multiply by speed mode. And we can play here by different values. For example, even we can write here to F. Probably it will be something very fast speed. So let's try to see how it looks like. Well, probably it can be seen that different cars move with a different speed.